Hello and welcome back to Engineers Olympiad, where learning meets success. We're doing the numericals of the first chapter, Introduction and Basic Concepts of Surveying, and this video lecture is also about the numericals, so let's begin. Question number 1 is, a rectangular plot of land measures 20 centimeters cross 30 centimeters on a village map drawn to a scale of 100 meters to 1 centimeter. Calculate its area in hectares. And if the plot is redrawn on a topo sheet to a scale of 1 kilometer to 1 centimeter, what will be its area on the topo sheet? Also determine RF in each case. Representative fraction in each case. So let's take village map first, right? Village map. What is the scale? Scale is 100 meter to 1 centimeter. That means 1 centimeter is equal to 100 meters. Every 1 centimeter on the map represents 100 meters on the ground. That means every centimeter on the map represents 10,000 centimeters on the ground, right? What will be the RF? Representative fraction. This is engineer's scale. This is representative fraction. It will be, right? So this will be the representative fraction for the village map, which is given that it has been drawn to a scale of 1 centimeter is equal to 100 meters. That means every 1 centimeter represents 100 meters on the ground or 10,000 centimeters on the ground, right? And the representative fraction came out 1 by this. Or we can say it is right. So what is area on the plan of this village map? A rectangular plot of land measures this much on the plan. So I'll calculate plan area first. How much it is? 20 centimeters cross 30 centimeters. That is, this is the area of that rectangular plot of land on the village map, which has been drawn on a scale of 1 centimeter is equal to 100 meters, right? Now, what does the question say? It says calculate its area in hectares. That means we have to calculate the area of this rectangular plot of land in hectares and on ground. What will be its area on ground? And we have to report the answer in hectares. What is area on the plan? 600 centimeters square. So what will be the actual area on the ground? Actual area on ground will be area on the plan or village map in this case. It is 600 centimeters square multiplied by the scale. What is scale? Every 1 centimeter represents how much? 10,000 centimeters on the ground, or the representative fraction is 1 by 10 raised to power 4. So what shall I do? I'll multiply it by the representative fraction or the scale. Every, students, please don't confuse yourself. Every 1 centimeter on the village map is equivalent to 10 raised power 4 centimeters on the ground. So I have to find the area of this rectangular plot on the ground. So it will come equivalent to 600 centimeters square multiplied by the scale. Every 1 centimeter represents 10 raised power 4 centimeters on the ground. But since we are dealing with the areas, square of it, right? So this will come equivalent to centimeters square on the ground, right? But we have to report our answer in hectares, right? We have to report our answer in hectares. So this is, right? Or if I have to report it in meters, it is equal to, or I may report it like this, right? to the power 4. So what is the actual area of this rectangular plot of land on the ground? It is 600 into 10 raised power 4 meters square. But the question demands its answer in hectares. And as you know, 1 hectare is equivalent to 10 raised power 4 meters square. Already discussed in the theory part of the lectures. So area will come equivalent to 600 hectares. Right? So we have reported the actual area on the ground and that too in hectares. So the area on the ground is 600 hectares. Now there is another part of the question and it says if the plot is redrawn. It was made on a village map first to a scale of 100 meter to 1 centimeter, right? Now the plot has been redrawn on a topo sheet with a scale of 1 kilometer to 1 centimeter. Now what will be its area on the topo sheet? Right? We have determined RF in this case village map. Already done. Now we have to do it for the topo sheet. Let me rub it first. Now we'll take this topo sheet. And what is the scale? 1 centimeter is equal to 1 kilometer. That means every 1 centimeter on the map represents 1 kilometer on the ground. So what will be the RF? Representative fraction will be 1 by, right? This will be the representative fraction because 1 centimeter represents this much centimeters on the ground. So RF will be this. So we have determined RF in the first case as well as RF in the second case. Now what does the question demand? Question says what will be its area on this topo sheet if the same plot of a land has been redrawn. First it was drawn on a village map, now it has been redrawn on a topo sheet. What was its area on ground? We calculated it 600 hectares, right? But if I have to report it in centimeter square, how much was it? It was 6 into, right? It was this much centimeter square on the ground, right? And here if I may report by representative fraction, it's so, right? So what will be its area on topo sheet? Area on topo sheet. What is the scale? That every 1 centimeter on the map is equivalent to this much centimeters on the 10 raised power 5 centimeters on the ground. So if I have to redraw this, how shall I arrive at the answer? 6 into 10 raised power 10 centimeter square is the area on the ground. But I have to use the scale. So I will divide it by this 10 raised power 5 because every 1 centimeter on this topo sheet represents 10 raised power 5 centimeters on the ground. So if I have to redraw it on this topo sheet, area on the topo sheet will be 6 into 10 raised power 10 centimeter square, which is the actual area on the ground, divided by the scale, which we have to use for this topo sheet. But since we are dealing with the areas, square of it. Six centimeters square will be the area of this rectangular plot of the land if it has been redrawn on a topo sheet with a scale of 1 kilometer to 1 centimeter. I hope you understood the question, right? So let's move on to the next question. Right. Question number 2 is, give the designation and representative fraction of the following scales. Give the designation and representative fraction of the following cases. What are the cases? Case number 1 is, a line 135 meters long is represented by a line 135 meters long is represented by 22.5 centimeters on the plan. And the next case is a plan having 400 square meters of area is represented by 4 square centimeters on the map. Right? It's a plot, not a plan. Right, so the question is, give the designation and representative fraction of the following cases. A line 135 meters long is represented by 22.5 centimeters on the plan. So what will be the representative fraction of the scale? Scale will come out to 135 divided by 22.5, which comes equivalent to 6. That means 1 centimeter is equal to 6 meters on the ground. Every 1 centimeter on the plan represents 6 meters on the ground. So this is engineer scale. So the representative fraction will be 1 centimeter is equal to 600 centimeters, or representative fraction can be represented as this or this. Right? Now case number 2. A plot 400 square meters in area is represented by 4 square centimeters on the map or plan. So the scale will be 400 divided by 4. But since we are dealing with areas, so square root of it, it comes equivalent to 100, which is 10. That means 1 centimeter represents 10 meters on the ground. Every 1 centimeter on the map represents 10 meters on the ground. So every 1 centimeter represents 1000 centimeters on the ground. That means representative fraction will be, or 1 by 1000, right? So this was the question, and this is solved. Let's move on to the next one. Question number 3. Question number 3 is, a surveyor measured the distance between 2 points. Surveyor measured the distance between 2 points marked on the plan drawn to a scale of 1 centimeter is equal to 1 meter, right? And found out it to be 50 meters. Right? Later he detected that he used a wrong scale. Of 1 centimeter is equal to 50 centimeters. Right? We have to determine the correct length and what would be its area. This is the first part of the question. And what would be its area if the measured area is, what would be its correct area if the measured area is how much? 60 meters square, right? So the question is, a surveyor measured the distance between 2 points marked on the plan drawn to a scale of 1 centimeter is equal to 1 meter and found out it to be 50 meters. Later, he detected that he used a wrong scale of 1 centimeter is equal to 50 centimeters. We have to determine the correct length and we have to determine the correct area if the measured area is 60 meter square. Now, this is the correct scale. I'll write it first. Correct scale. What is the correct scale? Correct scale is 1 centimeter is equal to 1 meter. Every 1 centimeter on the map represents 1 meter on the ground. That means the representative fraction will be right? RF will be 1 by 100. This is of the correct scale. What is the wrong scale? Wrong scale is 1 centimeter is equal to 50 centimeter. That means the representative fraction is 1 by 50. This is the correct representative fraction. This is the wrong representative fraction. And what do we have to determine? The correct length corresponding to this length, which he initially found out to be 50 meters. As we know, correct length is equal to representative fraction of wrong scale divided by representative fraction of correct scale multiplied by the measured length, right? What is our wrong scale? 1 by representative fraction of the wrong scale is, what is the representative fraction of our correct scale? 1 by 100. What is the measured length? So correct length will be correct length will be 100 meters, right? This completes the part A of the question. Now we have to determine correct area if the measured area is 60 meter square. Right, I write it down here. We know that correct area is given by RF of wrong scale divided by RF of correct scale multiplied by measured area, but the square of it. Right? So what will be the correct area? Let me rub it first. Correct area is representative fraction of wrong scale divided by representative fraction of correct scale square of it multiplied by the measured area. So the correct area, please do not confuse yourself. Correct area is, what is the representative fraction of the wrong scale? 1 by 50 divided by correct scale representative fraction 1 by 100. Right? Square of it multiplied by measured area. How much is the measured area? 60 meters square. So the correct area will be equal to right? So the correct area will be 240 meters square. Right? So we calculated the correct length as well as the correct area. This was a question dealing with wrong scales. Let's move on to the next question. Next question is, on a map drawn to a scale of 50 meters to 1 centimeter, a surveyor measured the distance between two stations as 3,500 meters. But it was found that by mistake he had used a scale of 100 meters to 1 centimeter. Find the true distance between the stations. We have to find the true distance between the stations. Right? So what is the question? The question is, on a map drawn to a scale of 50 meters to 1 centimeter, a surveyor measured the distance between two stations as 3,500 meters, but it was found that by mistake he had used a wrong scale of 100 meters to 1 centimeter. Find the true distance between the stations. What is the correct scale? One centimeter is 50 meters. That means 1 centimeter is 5,000 centimeter. Representative fraction 1 by this. Right? This is the original RF or the correct RF. Right? What is the wrong scale? Wrong scale is that it was found by mistake that he had used a wrong scale of 100 meters to 1 centimeter. That means he had used a scale of 1 centimeter represents 100 meters on the ground, which means 1 centimeter is equal to, and the representative fraction will be, this is the correct RF, this is the wrong RF. We have to find the true distance between the stations, because by mistake he had found the wrong distance of 3,500 meters. We have to find the correct distance between those stations as measured by the surveyor. What will be the correct distance? RF of wrong scale divided by RF of correct scale multiplied by the measured distance. What is the RF of wrong scale? How much? Measured distance 3,500 meters. So the correct distance will be which by calculations comes equivalent to 1750 meters. So the correct distance between the two stations as measured by the surveyor is 1750 meters. Right? So this was another question dealing with wrong scales. Let's move on and do the next one. Next question is MCQ type. Which of the following statements in respect of map A, let me write it down. Which of the following statements in respect of a map A having a scale of how much is the scale? 1:1000. And another map B having a scale of 1:5000. Is true. And the statements are, statement number 1, that map A is a large scale map compared to map B. Map A is a large scale map compared to map B. Second one is map B is a large scale map compared to map A. Map B is a large scale map as compared to map A. The third statement is map B is a more scale map compared to map A. Map B is a more scale map compared to map A. And the fourth statement is none of the above. None of the above. Right? So the question is, which of the following statements in respect of a map A having a scale of 1:1000 and another map having a scale of 1:5000 is true? This, or this. Right? Let's try to find out. Map A. How much is the scale? 1:1000. That means the representative fraction is 1/1000. Map B. What is the scale? 1:5000. RF is equal to 1/5000. Right? So this is about map A and this is about map B. And if you recall the discussions of the video part of the theory part of the same chapter, Introduction and Basic Concepts of Surveying, wherein when we were studying about scale of a map, which is the ratio that every distance on the map bears to the distance on the ground, and when we dealt with engineer scale and representative fraction, I told you that larger the denominator of the representative fraction, smaller is the scale. If the denominator of the representative fraction is large, the scale of a map is small. So in this case, whose denominator is large? So its scale is small compared to the scale of map A. So map A is a large scale map if compared to map B, because the denominator of the map B, representative fraction of the map B, is large. So its scale is comparatively smaller than that of map A. So map A is a large scale map compared to map B. So students, you must note that larger the denominator of the representative fraction, smaller is the scale. So in this case, this is a smaller scale map as compared to map A, and this is a large scale map as compared to the map B. Right? Let's move on. Next question is, what is the representative fraction for a scale of? What is the representative fraction for the scale of 10 centimeters to 20 kilometers? We have to find the representative fraction for the scale wherein every 10 centimeter on the map denotes or is equivalent to 20 kilometers on the ground. So 10 centimeter is equivalent to 20 kilometers, right? This is the scale. We have to find the RF or the representative fraction. So 10 centimeter is equivalent to 20 centimeters on the ground, right? So 1 centimeter on the ground will be equal to this much centimeters on the ground, or every 1 centimeter is equal to every 1 centimeter on the map is equal to 20 into 10 raised power 4 centimeters on the ground. So the representative fraction will be, or 1 centimeter is equal to therefore RF is 1 by right. So this was the question about the representative fraction. Let's move on. The next question is if the shrinkage factor is 15 by 16 and the original scale is 1 by 1500, representative fraction of the scale, then the shrunk scale will be, we have to find the shrunk scale, right? So this is the question. If the shrinkage factor is 15 by 16 and the original scale is 1 by 1500, then the shrunk scale will be, shrinkage factor or the shrinkage ratio is 15 by 16 and the original RF or the scale is 1 by 1500. We have to find the shrunk scale. And shrunk scale we know is equal to our original scale, shrunk RF rather. Original RF multiplied by the shrinkage factor or the shrinkage ratio. So our shrunk RF will be, what is our original RF? 1 by 1500. And what is our shrinkage factor? 15 by 16. So our shrunk RF will be equivalent to, our shrunk RF is 1 by 1600. That means 1 centimeter presents 1600 centimeters on the ground. Or we can report that our scale is 1 centimeter is equal to 16 meters. So 1 centimeter is equal to